work on day one, so hey, it's working, so that's kind of lucky. Now, at this point, we just kind of wait out the minute. So if you came into class right at 6 o'clock, I promise you didn't miss anything, unless there's a question asked by the class. It looks like it's time. Welcome back, everyone. I guess spring semester starts officially for this class. And this is a pretty weird class in the sense that it's really two classes rolled into one. I don't like the description of fully online all the time because I don't feel like it's always extremely honest about how the class really runs. Sometimes a fully online section only has one section going on for it, in which case I'm able to just focus on what's going on in Zoom. Other times, more often on this campus, they take an in-person section, that's us in the classroom right now, and combine it with the online section, that's, let me see if I can expand this here, these folks right here as well. And so that means for a lot of purposes, it will feel like an online class, but we have to be very careful about how the information goes backwards and forwards. So say, for example, if people are maybe not being picked up quite well by the microphone up here, and you're not hearing anything, just send me a reminder at any time in the Zoom section, and I'll read back the questions. That's going to be my habit mostly, but it's easy to forget those kinds of things. Another thing that makes this a kind of a strange fully online section is also there's a requirement for proctored exams at a testing center, only because math somehow hasn't found a way to do online proctored exams securely in a reasonable way that doesn't involve AI proctoring and a bunch of strange tools. But welcome to the class, folks. We're two sections altogether. And if you're curious how big this class is, take a look here. We're a class size of 16 altogether. That includes me, so 15. And that means these sections are, I believe, last time I checked, about pretty balanced, half in one, half in the other. Any questions or comments so far? Okay, and let's see, I don't think I had any other piece of information there. Usually what we do in the first day is discuss what's going on in the core syllabus. I used to take about 50 minutes reading it. I think that's probably better to just kind of go line by line, asking questions about certain elements. So we're going to kind of just more peruse through the syllabus. I encourage you to do a careful reading once you have time. After that, we'll take a look at what's going on the Moodle website. Since pretty much the Moodle website, this Corpse web page is where every single thing is going to happen relative to this class. Whether you're in the in-person section or the fully online section, it all happens here. So this is going to turn into one huge week-by-week resource. All I have programmed into it right now are just when the exams are, breaks, things like that, pertinent dates, such as President's Day holiday and so on. So we'll spend some time talking about the Moodle course, spend a little bit of time going through the syllabus, and depending on how our energy is, we'll take a look into our section 2.2 here. I don't want to go to the minute since usually on the first day, it's kind of overwhelming. There's lots going on. And usually I talk a little too fast anyway, so I need to kind of slow it down on the first day so that we're in a good shape when we come back on Wednesday. So let's start off right here. All the documents that we use in class are going to be posted to Moodle one way or another. Our first document is the syllabus. If there's any changes that ever happens on any of these kinds of documents, you'll see something in red here that says revised, and wherever the typo was or the correction had to be made would be in red as well. But here's the syllabus. If you've read one of my syllabi, then you've probably read them all except for pertinent things like the class changing. But just for the sake of going through it, let's see here. Probably class meetings we can skip through. Contact information is probably the next most important thing. You can reach me by phone. My phone's almost always silenced, and I do accept texts. But the probably easier way to get through me is through email here, or jumping into office hours, which are these times and dates. I also mentioned a lot of times in these classes, I probably should write it out a little bit more in the syllabus, but just for a reminder, when it comes to this email, it's really kind of being used as office hours as well, all rolled into one. What I mean by that is for any one of the classes I teach, if you have questions on the homework you're working on, problems you're studying on, you're always welcome to just send your work directly to my email. What that would look like is, pretend this is your work, just take, say, a scanner, scan it, a cell phone, take a picture of it, directly email your file to, I should have an email address somewhere, oh, that right there. Then I'll work on that email file together with you. I'll use the digital tools to annotate on it if necessary, that kind of stuff. And so the email is kind of like office hours. It's just a really, really slow. So it's not really effective if you have a question, say like at 10 p.m. for an assignment that's due the next day. It might be a little bit frustrating in that sense. But if you have questions lined up that you know you have time to come back to, that's pretty effective. Next way to get in contact with me is just through these office hours. I actually had one person that hit these office hours today on Monday, 4:15 to 5:15. That's always hit or miss on the first office hours of the entire semester. But I'm always just available in Zoom at these times, 4:15, 5:15, Monday and Wednesday. You don't need an appointment whatsoever. I'm just waiting for someone to drop in. I also have drop-in office hours. This is more for the in-person section, section 4, since this is in room CHE 220. So you can drop in at 1 to 2 p.m. This is on Tuesdays, and 4 to 4:15 p.m. on Thursdays. So that's what my office hours look like. I have a pretty complicated schedule on Wednesday. So occasionally I might have to move the 4:15 to 5:15 up a couple hours, but this semester I'm not going to outright cancel those hours. We're just going to rearrange it all happen. And I'll have a lot of lead time into the calendar to let you know when that might happen. So that's the best way to get in contact with me. Any questions at the moment? Okay, other things you can do if you just want to get a quick contact is you can also just use Moodle website, directly email me here. Usually when that happens though, is it bounces an email to my Gmail account. And oftentimes I don't even know a message happens here. I do the reply on the Gmail account, but you're welcome to use that as a separate avenue for contacting me. Other thing that's more exciting about this, so this is the textbook. So this textbook was selected by Dr. Tracy Payne, and it's a phenomenal textbook for our course. And it has a freely online earlier edition of the textbook. I've been studying it, I've been reading this for the first time, and I have yet to find a really major difference from the freely online version, even on the homework sets. So I'm going to be keeping a really close look at this, but it looks like if you don't have the text yet, give this one a try. I don't even see a difference on the homework sets yet. If I do find a difference on the homework sets, what I'll do is just publish a PDF of the most recent edition homework set. That way, if you're using this online version here, you should be pretty much all set up for the course. Even if you have the textbook, it's just kind of nice to have this resource. Clicking on here takes you to a bunch of other things. This little website, it looks really kind of archaic and out of date, maybe a 2004 website. But what matters is the content. You can click on, say, Chapter 2, Basic Data Types. And this is the whole Chapter 2, 94 pages. Every section, the exercises are in here, and so on. So it's a kind of a nice book in that sense. One thing that people probably won't like about it as much is this textbook doesn't have answers to odd or even exercises whatsoever. I mean, the publisher's got to have the solutions, the author, I mean, but it's not freely shared. I don't know who has the solutions to these things, odd exercise or otherwise. So keep in mind on that when I'm assigning these homework sets that none of these have solutions. And so once again, you're heavily encouraged to drop in during office hours or directly email me if questions comes up on any one of those problems, because that is an extra thing that's a bit tricky, I'd say, about this text. So we save money because it's freely online. There's a pretty cheap version you can also get if you like a hard copy, but it is strange text in the sense that it's not standard like some of the bigger publishers with odd exercises. But any questions at all, folks, about the textbook? Okay, I think it's kind of rare to have a free textbook that is just as good as the real PDF or hardcover. So that's a wonderful resource for this class. Aside from this, we have information on the prerequisites you have to take a look at. The course objectives, we can pretty much see through the actual textbook itself, looking at the table of contents. But this gives us a good idea of what we're really getting into. Some of the topics I'm really interested in looking at again are set theory for sure. Set theory is one of those things where whether you're into mathematics or other things, being a little bit foggy on how sets work makes a lot of mathematical content very, very difficult out of nowhere. So that's a really fun fun section to be working on. But really, logic and proofs is kind of the meat and butter of this section. We'll be spending a lot of time with these objectives. What else here? But besides that, things like number theory, combinatorics, graph theory, trees, sequences, this is where we're looking at additional topics once we go beyond the main meat of the course. So think of this as the major mathematical objectives, and down below, these are more of the applications that we're going to be getting into right after the last two bullet points. So that's what we'll be doing in this course. It's an odd course because it's designed to prepare students with the mathematical knowledge necessary for a computer science degree, but it's not a course where we do much coding whatsoever or computer science. We might analyze algorithms, at most do a little bit of pseudocode, but we're not going too far into the coding direction. That's kind of weird. It might make some people feel a little bit good about this course. Other people probably have a gargantuan amount of coding experience under your belt, and you might be wondering why we're not doing so much of that. But keep in mind, it's also one of those classes where there are not a lot of prerequisites to it. It is a pretty, well, it's a 100 level class, I guess is what I was trying to indicate. Well, aside from the objectives, we're going to have homework that's going to be assigned on a section by section basis. So what I mean by that is our first section is section 2.2. So the assignment 2.2 is relative to that section. And as far as the due dates go, this is indicated at January 22nd at 6 p.m. What that means is I feel like we'll probably finish this section on the 15th of this week. I always give a 1 week turnaround on all the due dates. If we don't finish it on the 15th, no worries. That means we would finish it on the 20th, and the due date on that would move over to the 27th. So whenever the assignment is completed, it's always a 1 week turnaround. I found it's easier to put in a due date right away and then move it as necessary as we go through the course. So that's what the homework assignments will look like. They'll indicate the problems. Here they are. It looks like a lot, but our author indicates the section and then the problem number. So if you see a 2.70, that's section 2, problem 70. It's kind of clunky to write these all out. That means you would either go here to the freely online text or your hard copy physical textbook, go to section 2, and the problems are just right at the end of the section. Section 2.2 is rather long because it's one of those sections where we're trying to get everyone on the same page. Not every section has this many concepts in it, but once you get to the end, you'll hit this kind of stuff, the computer science connections. This is part of the reading, but I do consider it optional. And even if you haven't done much computer science, this is some great stuff to take a look at. It shows the immediate application to the content you were studying right away. There's no assignments that come directly out of it, but think of it as just kind of an enrichment type topics to what you were just looking at. And finally, down below, this is where the exercises are. So pretty much it's just going to be an experience of solve these problems in a traditional way, and then you're all set. Definitely more to say about, oh geez, I'm losing track of where I'm at here. Definitely there's more to say about the homework, but any questions so far?
Professor, I have a question if you don't mind.
Not at all, go ahead.
So is there any real benefit besides having it as a physical copy for the newer textbook versus the free one for right now?
I would say the only benefit is learning preferences. For me,
Okay.
for example, I learn better if I have something that I can actually grab when I'm reading something, but that's going to be the only actual benefit. I'd say your learning preference.
All right. Thank you very much.
Yeah, absolutely. Other questions so far? Okay. One of the things that I'm trying to get in the habit of doing, I tried to do it last semester, but it's one of those things where you have to remind yourself constantly. I'm going to try to give long pauses after I call for questions. Between 5 and 10 seconds, that can get kind of uncomfortable, I know, but that just means allows people to kind of collect your thoughts. If you're in Zoom, you might be typing out a message that you delete if I just ran right through it. So sometimes I might pause for a while. It's not any kind of mini seizure or stroke or anything, just giving everyone a chance to collect their thoughts, a small pause in the course. But other things I want to mention about the homework is, let's see here. We have a policy where I'm going to drop the lowest two homework sets at the end of the course. But probably more interesting in this course is you're heavily encouraged to work in groups. Let's see here. Did I say that? Somewhere. Working through the homework sets in groups is encouraged. I'd say, again, that's probably one of the best ways to learn mathematics of this kind, of really any kind of mathematics. Working in groups just kind of forces you to explain things to your fellow student. And if you can explain something, that's a really higher order of type of learning where you're really making strong connections that don't just die off from sitting down in an exam setting. In other words, the more you can talk about the work you're working on, and particularly with your peers, the more robust the knowledge is that you're going to pick up from this course. So if you're working in groups, I think that's fantastic. The only ask about that is you do have to write your own original work. So it's not saying copy assignments or anything like that, but definitely collaborate on problems. Finding solutions is a great way to go. I put some other information here about providing step-by-step solutions, showing your work is expected on the homework assignments, for example. There'll be an emphasis on correct mathematical notation, but maybe not as heavy as it might have been in a calculus class, for an example. And I wrote here, answers must be given in simplified form, exact form, but this is really a context thing. You'll know from the context if an approximation is expected or if an exact value is expected. If you're not sure, never hesitate to ask. I'll be happy to clarify. So that's how the homework works. But again, probably you're still a little bit concerned because there's 2 sections in this class, which means there's a lot of lots of ways to actually turn in the homework. So I indicated down here 3 common methods that have been used in this class. Let me zoom in on that. So if you're in the in-person section, a lot of people sometimes just take their lined notebook paper, solve your problems, write on it, and hand it in as a hard copy at the start of class or at the end of class, and that'll always work out just fine. If you go this way, that means you have a little bit of a turnaround time before you get your assignment back, since I'll hand it to you the next time I meet you to give you back your physical copy. So this is the fully traditional way. It doesn't work for the fully online section, so there's got to be other ways. Still, if you want to work in a traditional way, and you're in the fully online section, you can still write down your problems on ordinary lined notebook paper, things like that, and just send your email to me by taking a picture of your work and sending it to this email address here. I don't actually have a spot in Moodle where I collect the assignments. I've had problems with that in the past, and I found just direct emailing is by far away probably the best method. If you do send in your homework this way by method 2, and again, everyone in the class, whether you're in the in-person section or the online section, you can hand these in either way you'd like. But method 2 means you're going to get your work annotated digitally and emailed right back to you. The third method is you might just decide to do the problems in this section by opening up maybe something like Word, your favorite whiteboard, and just working on your problems completely digitally. I've seen a lot of people take the strategy of, say, imagine this is the homework problem we're about to solve. Imagine this is really the textbook that we're taking a screenshot out. A lot of people build a digital file this way, use a digital pen, and just start marking things up. And you're welcome to save that as a PDF, directly email it to me. If you do it that way, I'll use a green pen to say, these are my marks here next to say, here are the feedback. I try to provide enough feedback to let you know why you might miss something, what could have been missing, ideas that could have been used, and so on. I'll always try to use green or maybe a different color that helps a little bit more. So those are the various ways you can turn in your homework assignment for this course. Probably we'll have a little bit more questions on that as we get closer and closer to the first due date. But that's how all these assignments are going to work. Any questions about that so far? Okay. Another thing I would mention about the homework assignments are there's a definite process where you save the most amount of time if you get into a right process about thinking about how to study for the course. I'd say the best way to absorb new material that you've never seen before is definitely start with the reading. So on every homework assignment, I'll indicate what the relevant pages are for the reading. Section 2.1 is a really short blurb about what the course is all about, so some of you may have read it already. Then section 2.2 is these pages 6 through 17. It's a little bit more, but then I say, and pages 20 to 22. This is kind of my way of indicating we won't cover every single concept on every single section. Sometimes we do have to skip around, And this is a way for me to not waste any of your time. You can read it, it wouldn't hurt you anything, but this is me saying the problems down here are directed from these reading right here in particular. So if you do the reading first, you're in really great shape for getting taken on these problems. In fact, you could do them right away if you'd like, or just wait for class to start. The notes always look about like this, and I design all of my course notes to give examples, not that one, it just says example, it's illustrating a definition. I try to give examples that are highly relevant to what the actual homework assignment looks like. I compile the homework assignment first, then I start writing down my lecture notes to make sure they're well targeted. So I'd say read the book first, come to the lecture, and the lecture is going to make a lot more sense. Even if you just barely skim the textbook, it's amazing what your brain is actually picking up. So if you come to the lectures and you didn't take a look at a textbook at all, it is a little bit tougher. And sometimes that happens, our schedules are busier, but I encourage you, try to do as much reading as possible before class, and you'll be in great shape. The problems down here will be highly relative to the problems that are down in this set as well. It feels like if it ever feels like one of these problems are just an odd one out, don't hesitate to email. I'll be happy to talk about that one. And maybe it really is an odd one out that didn't appear in this section. That'd be extremely helpful for the entire class, since I'd probably want to make a little bit of an attachment to that and actually talk about that in class to support the problem. So that's how all the lecture notes, homework assignments are going to work in this course. This file right here gets updated with everything that we do at the end of the class. So if you clicked on this file already, with the intent of printing it out, you're in great shape. We didn't do anything to it. But if you try to print this one out on, say, Wednesday's class, it's been marked up a whole bunch. Some people might like that. If you ever want the blank file, they're all going to be sitting right here under blank lecture notes. Well, one of them so far. And you'll also have a Word document as well, if that's a preferred format. I'm usually publishing the PDFs just for the sake of extra compatibility. So far, that's pretty much the meat of the course. And the other big thing is after examinations, where am I? We need the syllabus. After the homework assignments or the examinations, we'll have 3 standard exams, 75-minute exams in this course, a comprehensive 2-hour final exam. For the exams, they're going to be closed notes and closed book, but I will be attaching formula sheets at the last page of all the exams. And I'll try to get those formula sheets indicated soon. What I mean by that is, on our first exam here, I have one document of what allowable calculators are, but probably by the time we're at the weekend of this week here, I'll have a file ready to go to say the formulas that you could expect to see on the last page of exam 1. That way you'll know what you are expected to memorize, what is going to be provided on the actual exam. Also, we'll be publishing the standard kinds of things like review problems, the exact coverage of what's on exam 1, and so on. So everything you see here starts to get built out more and more as we get closer and closer to that exam week. So lots more things to talk about here, but let's jump down to the grading part. Unless there's any questions at all first. This is a good spot to pause on. Okay, that was about 10 seconds. It is uncomfortable, but at least it gives us a chance to kind of collect our thoughts and everyone a chance to respond. As far as the grading goes, I take a slightly different approach, I feel like, from a lot of my colleagues when it comes to homework. Really, my philosophy of teaching is homework is the most important thing. Me giving you feedback on your homework is probably the second most important thing, but this is really where all the learning happens. It's extremely tough to study for an exam if you didn't put in the homework efforts on week 1, week 2, week 3, all the way leading up to the exam. Think of the homework as you really are studying for the exams in and of themselves, because just like the lecture notes are derived from the homework questions I asked, once I go to write the exams 1, 2, and 3, I take a review of all the homework problems that we asked, all the lecture notes that are published. I base my sample exams on them and the real exams on them as well. So if you're doing great on the homework, the exams, of which they're 15% each, they're not going to be too big of a deal. And the final exam will be 25% of the course, but it's just going to be a rehash of primarily what was in exams 1, 2, and 3. And let's see here. After exam 3, we might have one more class on Wednesday, I don't expect that to be a whole lot of content. So the final exam is comprehensive. It's essentially exams 1, 2, and 3. Well, there's the standard grading scale down below. Going down beyond that is the day-by-day syllabus. But any questions at the moment about the grading or otherwise? Okay, so really, I'd say the number one thing that you can do to be successful in this class is treat every one of those homework assignments as if you're really studying for an exam. That's a really great mindset. Write them out as if you're writing down an exam solution, and you'll just happen to learn everything just from all that work. It's really hard to do all this work on those problems and somehow not memorize key facts about what's going to be on the exam. It's really kind of strange. Stuff just has its way of kind of leaking into your subconscious after a while. So next is the day-by-day schedule, syllabus. I'm going to double check this, but this is probably correct. This is indicated by a registrar. They treat us as a night class, and on this campus, they put all the night classes at 8 to 10 p.m. That's really pretty rough. There are other options sometimes with my final exam. Sometimes I do give an earlier one, and I allow students to join that earlier final exam, but apologies for that final exam time. I do write the final exam with this in mind, that that's not an ideal time for anybody to take an exam. And it is the one exam I do curve, again, partly for that reason there. So the only thing that's firm about our day-by-day schedule are the exam dates. So the 10th of February and so on. It's kind of a strange schedule when you look at it. We already have a holiday here, another holiday here. So for what's supposed to be a 16-week class, we lost a week. We're down to 15. This is a closed week, I learned. We're not supposed to cover new content on this week. We'll be purely reviewing. So that's like we're down to 14 instructional weeks that we'll spend as much time as we can learning the content. I didn't say what sections we're going to be on because, well, this is the first time for me personally reading the book. We'll have some extra play here, take a little bit of extra time on sections that need that time. And if it looks like we didn't need as much time in chapter 4, we might spend more time getting into chapter 5 early. If chapter 4 looks like it's a bit of a bearable chapter, we'll take an additional time on working on that one. So again, the only thing here that's firm are the exam dates. But aside from that, I think that's the whole entire syllabus at this point. I encourage you to carefully read these statements down below. This is written by various people across the Pocatello campus. Statements on accessibility, academic integrity, and so on. There's really quite a lot. Title IX probably being the most important one. Maybe that should have been first. But anyways, they're all important in my opinion. It's a good idea to read these if you've never seen those statements before. If you have seen them before, they're probably exactly the same. But that's the syllabus, folks. Any points on there that you would like to spend any additional time taking a look at? Okay, well, let's close this up. Move up to the top, and pretty much this is the experience anytime you come right into a class. I'll always have the Moodle website pulled up like this, Zoom opened up. I try to get Zoom open soon, so if you have questions and you're coming in through Zoom, I will be available before class starts at 6 p.m. And I try to get into the physical classroom right about 5:30-ish, so I can get everything set up before class starts. Then you'll always know what section we're about to work in. We're in section 2.2. For me, I'm using Word, so I usually have my documents duplicated here to the thumb drive. And this is where pretty much the course would start in earnest. It all goes on a document definition theorem basis with examples down below. And so again, think of this as just one big whiteboard that we're working on. Any edits that we put onto this at the end of the class will be shown on this PDF here. So think of this PDF as constantly being updated. But I guess we're ready to start. We're now in section 2.2, dealing with Booleans, numbers, and arithmetic. For a lot of people, that might be a new word. It's based off a person named Boole, who first started working with these objects. But for the real sense, this is probably one of the bigger part of the course, dealing with Booleans. So let's go through the definition. A Boolean value is either true or false. This is an exclusive or, it can't be both, obviously. So either true or false, definitely not both. And it says here just a quick blurb, Booleans help us make decisions in code. I have an example below because when I read through the book, there's actually no homework problems or real problems working with Boolean values, just a kind of a quick blurb about them. But let's do our own example here. Anything that says example without a number on it, think of this as really just being our goal of just trying to illustrate what the definition is trying to say. So probably the best example of a Boolean, well, in my opinion, is a light switch. Because in a real sense, that's what a Boolean is. It's a type of switch. A light switch has exactly two states. So we can say state one, the switch is off. State two, the switch is on. So that's one way to analyze the two states of the light switch. Once we do that, we can assign Boolean values to them. And there's lots of ways to do that. Sometimes we'd use numbers like 0 and 1 to represent Boolean values. 0 would be representing false, 1 would be representing true. Or we could just come down here and say, for on, this will be the value true. Off, this would be the value false. And these are the Boolean values here. So we have two states for a particular system. We could use Booleans to code them as either true or false, depending on what the state is. It says here, this helps us make decisions in code because now you can do something along these lines. If it's false, you can tell your code, do nothing. If it's true, depending on what you're designing, who knows what's going on in this example, maybe you tell your code to turn on a coffee machine. Not sure if that would really save a lot of time in your day-by-day life, but people do weird stuff like this just for the sake of fun. And this is where the Boolean value comes in the middle. So this is a really strange section 2.2 out of the book because Boolean values is the thing we're probably least familiar about. It's the most important thing probably in the whole book. And this is all I got for you. We'll definitely be coming back to this, but it's a good way to introduce the course as the objects that we'll be working with all along. Again, section 2.2 is kind of big. It's got a lot of weird stuff in there that doesn't really necessarily seem related, but it's a get everyone on the same page type of section. The homework problems might seem kind of simplistic at first, but they'll be more interesting as we go on. So if it seems kind of boring for now, my apologies. The course content will definitely get interestinger as we go. But any questions or comments at all, folks, with the information here? Okay, going beyond Booleans, we also have basic objects we'll be working on, numbers, and our operators, the arithmetic operators. I felt like this is a good time to just take a good inventory of common notations like this and here down to this R. So motivations of why we have these kind of number systems, because these are notations that we're going to see come back quite a bit in this course. First, there's the natural numbers. Our book doesn't define them, but it's a real starting point. Historically, this is where numbers started, the natural numbers, just for the sake of counting stuff. And it's kind of amazing when you look into the history of mathematics. Zero took a long time to really get introduced and used in the usual way that we use it. The concept of nothing, zero things, is kind of slippery in the history of mathematics. We can think of the purpose of extending the natural numbers to the integers as wanting to solve a type of equation. The equation x plus 5 equals 5 has no solution to natural numbers because there's no zero in this number system. So if we extend to z plus, the non-negative integers, we're in business. The solution was 0, and now that's an actual number we can deal with. But this kind of game, it doesn't go forever, but it goes for quite a while. There's a problem with z plus because you can extend your equation to something like this one. Almost the same equation, but now we have a problem. The solution is -5. So we extend to the integers. This is the first big number system that we're using. And the z here comes from the German word for number. So the Germans have indicated z is the way that we indicate the integers. Interesting choice. And I think that German word, let me know if you know more German. I think it's Zalen, something like that. I probably misspelled it, but that's the idea of why we use Z to indicate the integers. And the integers are great until you try to solve these kinds of equations. It's almost not fair. All of these are linear equations, but if you change your linear equation just right, your number system is too small. So this equation has that as a solution. It's not an integer whatsoever. So we extend our number system to Q. Q makes a little bit more sense. Q means quotient. Quotient because we're dividing things. Even if you take an integer of -3, you could take -3, write it as -3 over 1, and now it is in Q. So all of the integers are a subset of the rational numbers. They belong to the set. And this is suddenly becoming a very large set of numbers. You could solve just about anything approximately inside that system. If you want exact solutions, now we're upping the degree to degree 2, you've got a problem already with the quadratics. This one has solutions √5, -√5. They could be extremely well approximated by rational numbers, but if you really want these solutions in your number system, you need the set of all irrational numbers. This is where number systems get pretty interesting. There is a lot going on with the irrational number system. If we take Q, all of the rational numbers, I, all the irrational numbers, and perform a union. So this U right here is saying, oh, that's not a U in that sense. Let me try again. This U means union. In other words, it's Q union together or placed together with the set I, irrational numbers, and we get the real number system. We're at this point at a continuum, so that's great. But even though we're at a continuum and we can solve some polynomial equations, we cannot solve them all. For example, this equation still has no solution, yet if you extend the number system farther, you get complex valued solutions. We're not as concerned with complex numbers, but our author mentions they have a weird way of coming up, even when your book never tried to work on them in the first place. So I thought it was worthy to just put it here just as a reminder they could come up here and there. We'll mostly be working with the real number system and their various subsets indicated above. So those are our number systems. We're all familiar with these to various great degrees, but we'll get the opportunity in this course to look at them even closer. Well, down below is just our author's way of indicating this information down below as well. Any questions at all, folks, with where we're at so far? Okay, well, going further in the notes. Again, this is a long document. We've got 6 pages to go, but here's page 2. The idea with example 1 is we're talking about number systems, well, sets of numbers. It's a good opportunity here to think a little bit more about sets of numbers. Section 2.3 is all about mathematical sets. And these ones here and here indicated through interval notation are sets in their own right. So this is one of those problems where you really don't have to work too hard on this. Let's make a big deal out of this problem anyways, to get a good feel of what's going on with the interval notation, kind of as just as a reminder how it works. And then we can deal with this information here. This is a problem that probably makes a little bit more sense when you're dealing with sets. We're trying to do a kind of intersection in a certain sense. But let's just do this one directly. Because it says example 1, this is a problem that you can expect to be somewhere in your actual homework assignment. Now, because we have 2 sets going on, let's actually start off this way. Let's color code them together. And because they're actual mathematical sets, there's lots of ways to write this out. For example, 19 to 25, we could write this way. Once I fix this document, there we go. It's a set of all x such that 19 is less than x, less than or equal to 25. The next section is about sets, but we can't avoid it. Sets are just everywhere. Our author has to write out sets even in section 2.2 before that section 2.3. When we write these out, this colon is read literally as such that. Other books, instead of using a colon, might use a vertical bar. So if you see sets indicated this way, then you're reading the same exact information. Our author goes with the colon method. So that's our first set, all x's between 19 and 25. But notice the information here, we're dumping the boundary value 19, we're including the boundary value 25. That's what the parenthesis bracket is trying to indicate. And because we did it once, we should do it once more just for this set here, 2130. Written as an actual set goes, we start with a curly brace to indicate here's a mathematical set. It's a collection consisting of x's such that there is a particular condition that all x's have to meet. They must be between 21 and 30, but more specifically, it will include the boundary value 21, exclude the boundary value at 30. So that's our setup so far. We want the smallest and largest that are in the interval 19 to 25, but not in the interval 21 to 30. So our answer will be down below. Here is the max and the min. Once we spot these values, our work is done. Any volunteers for either one? This is one of those problems where I'm really tempted to say 19 for the minimum. That's probably not a good idea, right? There's troubles right here, but there's also other troubles. It said largest integers. So our answers can't be things like saying 19.5, just for an example. They have to be actual integers that we're selecting. So just as a reminder, they have to be these things up here that we're selecting. One way we can take a look at this is we could just draw them down a number line. Let's put our numbers on the number line, starting with this one, 19 to 25. Standard way to write this down is, right at 19, we exclude the boundary, we put a little open circle there to indicate it. Over here at 25, we're including the boundary, so we put a little solid dot here to include it. Now the shading in blue going this way is all elements of this set from 19 to 25. Let's do it again, 21 to 30. These are the values we said, but not in. So our answer can never include anything that's in green. It goes from 21, let's just place a value right here. That's a bracket, so it'll be a solid dot at 21, up to 30 with an open circle. So every single thing we wrote down in green is now excluded. And again, we can't even put 19 down here for the minimum, because the minimum would be this one, 20. It's the value that's actually in the set itself. So I have a minimum value of 20. Anyone spot what the maximum should be?
Maybe a shot in the dark, but is it 20 as well?
It is 20 as well. Kind of a weird example on this one. It can't be 21 because it said, but not in 21 to 30. So for this one, the minimum is 20 and the maximum is 20 as well. So good call on that one. I actually wasn't expecting that. I probably should have solved this problem before coming to class. It was kind of a surprise to get both that as an output. Doesn't happen in your homework set. I think the homework problem is a little bit less tricky. But again, this is a tricky problem because in interval notation, like you see here by the red dot, that's a subset of purely real numbers. But what we're trying to grab is the integer. So this is all about what domain are you really working on and what are their sets themselves doing to interact together. So even though it seems like kind of a simplistic problem, it is a problem that if I did this much work on it, hang on, I'm trying to scroll to the right part. If I did this much work on this problem, just read it and try to say the min and the max, really strong chance I'm just going to miss it. Because these are really subtle things. We really have to get another view on what's going on. Any different way you can write out the information, maybe as a set, maybe as a number line graph, is massively helpful. But that's one down. Again, it's kind of light example. Today, it's all about getting everyone on the same page of the class. We're not trying to do anything too heavy on the first day. Any additional comments on this one? Okay, let's see where we're getting into next. So after number systems, we have some operations on numbers. First is the good old absolute value. Everyone's familiar with this one. What you might not be as familiar with potentially is the case-by-case way to indicate absolute value is indicated this way. Absolute value of x is itself if x happens to be non-negative, greater than or equal to 0. And it's the opposite of x otherwise. That is, if x is less than 0. Another way you can write down absolute value of x, which is sometimes algebraically pretty helpful, is square root x squared algebraically is absolute value of itself, absolute value of x as well. So 3 different ways to think about this. Absolute value of number is just a directed distance from 0. It's always going to be non-negative. Or it's a case-by-case function, or it's just the algebraic expression square root of x squared. The new stuff here is floor and ceiling. There's 2 schools of thought on this one as well. Sometimes people think of floor as round down and ceiling as round up. That's not a bad way to think about it, but it is kind of concerning. You have to be really careful if you're thinking about floor as round down, ceiling as round up, in particular when you're dealing with negative numbers in that situation. Because rounding down, rounding up, you have to have a mind of where you're at in the number line to know which direction you're really going. It can be easy to get mixed up on those things. But for our author's full definition, the floor of a real number x, written this way, kind of makes sense. It's a bracket that goes like that to indicate we're interested in the floor more than anything else. It's the largest integer that is less than or equal to x. So that is the full formal statement. And we have a floor function that we're calculating right here on part A. Let's do the floor of this one right away and then move over to the ceiling. So if we're doing the floor on this, the very first thing we need to do is take this irrational number e and get a good approximation going. I'll often be using the Desmos calculator as just a fast way to demonstrate a computation in class. You don't have to use it yourself. It's no requirement whatsoever. The number e is exhibited to be about this, 2.718 and some change. So let's put that in. We're doing the floor of 2.718. I'm going to copy our author's notation here with writing down decimal expansions. It's kind of a weird way if you haven't seen this done before, but those dots, dot, dot, dot there, it's not me saying I'm rounding. It's me saying I've got the number down accurately, fully accurately to 3 decimal places, and there's a whole bunch more. But you can be assured these are the real first 3 digits after the decimal point. Our author does this method a lot whenever writing down a decimal expansion. Now we're ready to get the floor of this quantity. Let's go back to the definition. It's the biggest integer you can find that is less than or equal to 2.718. Anyone spot the floor on that? Thanks for spotting that one. And again, we're essentially rounding down in that sense, right? We'll be very careful with the negative 2.81732. It still is rounding down, but because it's negative, you really want to think of the direction you're going as well, all at the same time. But we got it, folks, on part A. We calculated the floor of just one thing. 2 is the largest integer that's less than 2.718. 1 is also less than it, but 2 is larger. So just as there's a floor, there's a ceiling. With ceiling, you're often thinking rounding up. And the notation changes in kind of a clever way. If this one's the floor, the ceiling goes like this, just to kind of indicate to you everything is about the ceiling, rounding up now. So next one is getting a little bit more involved. It's the ceiling of a number, 36/17, to the power of the ceiling of a whole nother number, but let's give it a try. So this will turn into, first let's operate on 36/17. We need a decimal expansion on that. I've got a 2.117. So that's that figure, accurate to 3 decimal places. And here we have the ceiling coming up again for the exponent. So our penmanship suddenly becomes really critical here. We need to write this part to make ourselves believe it really is an exponent. So, well, I guess we could recopy it here, and then we'll calculate it next. Negative 2.81732. Okay, oh, messed up again. One thing you don't want to do when indicating the ceiling is round out the bottom part. Makes it a little vague what you're even doing. So I'll try to keep those notations just right. Oh, it was. That was a missed copy on my part. Right when I was saying I need to be careful writing these down. Thanks for spotting that one. So this one should have been a ceiling for the base, just as you said. I like that you called it the base. That's exactly what it is. Raised to the exponent, which is also a ceiling. Okay, I think we're in good shape. And let's take some options from the class. Anyone see what the ceiling should be for 2.117? Absolutely. We round up to the next integer, 3. How about another volunteer? What would happen to the exponent? -1. Negative 2.8. You know, that's kind of tricky. Let's put this down on a number line. We're rounding upwards. We're at a -2, -3, -1. That value in question is right here. Negative 2.81732. And you're absolutely right. If we take the ceiling on this one, we are rounding up to -1. Good call on that one. That one is the one that bothers me the most, those negative values.
2.8 be closer to 3?
Oh, hang on. How did I draw that? I put it, oh, and that's like a -1 point something else. Sorry about that. That was my mistake on the number line. Thanks for spotting that one. So my negative 2.8173, like you said, is closer to -3. That changes our response on this one. That means the ceiling on negative 2.8173 is the -2 rather. Sorry, that was my bad. If you mess up the number line, it's not going to help you out at all, it turns out. So be careful with that if you use this strategy. So the ceiling is now -2 on this one. That makes sense to everyone so far? Okay, that means we're in business. We can calculate this thing. We have 3 power -2, which means we're dealing with 1 over 3 to the power +2 through exponent laws. And so the whole result of the ceiling of 36/17 to the power of the ceiling of that is just a 9. Weirdest way in the world to write a 9. Well, any questions at all, folks, with getting through that one? Okay, thanks for the feedback and support on the class on getting through some of these, especially on the day one. I think I just tend to talk a little too fast, get a little too frazzled, but we'll get through this together. How about let's make part C our last one for the day. Then we'll end class a little bit early since it's just the first day. I'll still be available in the classroom to take questions as well if you have any questions after class. So let's try this out one more time. We have the absolute value, since I felt like we should use that at least once if we put it on the notes, of the ceiling of pi minus the floor of square root of 2. So really the good way to start this one out is just approximate some of these values. We have absolute value of the ceiling of 3.141. So there's our pi coming in, minus the floor, square root 2. I think that's about 1.41. Let's take a look at that. Not at all what I want to click. Hang on. The tilde button is too close, I guess. So square root of 2 comes out at 1.414. So 1.414 should go here. We'll take the absolute value of the difference, and then we'll be on our way. So first, these ones are not as tricky since we have no negative values here with that extra trickiness. The ceiling of 3.414, that should be just 4 itself. We're rounding up to the next integer, minus, sorry, things are a little bit weird to get used to on the first day, I guess. Minus now next, is the floor of 1.414. Well, the floor of that would just round down to a 1. So now we're looking at the absolute value 3, which comes out as 3 using the top branch right here of the absolute value function, but we expect it as 3 anyways. So that's really some of the new content. I expect a lot of people have dealt with ceiling and floor functions before, but we'll deal with them actually quite a bit in this class. So I'd say this is the part where the class really gets going in this portion. Any questions at all, folks, with those 3 examples there? Okay, just to give you an idea of what we've got going on when we come back on Wednesday, we're going to be dealing with exponentiation, property of exponentials. Again, think of this as another place where we're just getting everyone on the same page. We'll do a by-hand computation, simplifying this thing down. More interesting is logarithms. They'll have a lot of reasons to come up in this class. So we'll do some computations with logarithms just for the sake of getting a feel for them. After that, this is much like when we were dealing with floor and ceiling. This is a more direct part of the course that we're majorly interested in, not get everyone on the same page type problem. We'll be dealing with modulus, which means we're dealing with division. The modulus of a number is just the remainder upon division. But the floor function starts to interact. So that's kind of a nice thing about some of these functions. They don't exist in isolation. We can combine them with lots of other things. We'll end our discussion dealing with summation notation. Nothing too major. And that's going to be the content for our first section. Well, I think this is, again, a good stopping point for us, folks. We'll end about 20 minutes early today to give people a chance to ask questions after class, that kind of thing. Also, when we come back on next class, we'll be able to dedicate pretty much the entire class on getting through these sections. I should have the 2.3 notes posted as well, in case we get that far. But have a nice night, folks. If you have any questions or comments at all, I'll be happy to help out. Otherwise, I'll see you all in Wednesday's class.
Thank you.
Yep, have a good one.
I have a small question regarding like how you want us to write the problems out. So do you want us to write exactly how you did out here? Or like, for example, for problem C, could I just skip to the 4 minus 1 part? Or
Yeah, absolutely. I'd be very happy with that. I'd add a lot of detail to the notes just for the sake of kind of making them readable, helping to connect the dots if you came back here. But if you're showing steps and you're making a reasonable leap like that, I'd say that's terrific. I just assume that you visualize pi as 3.141. You wouldn't have to show it.
okay, perfect. Thank you.
Yep, absolutely.